In this video, I'll show you how to connect an external LED to an Arduino and program it. I'll also explain how to use the built-in LED on the Arduino UNO. To follow along with this tutorial, you'll need an Arduino UNO, an LED of any color, a 220 or 330 ohm resistor, the breadboard, a USB cable to connect the Arduino to your computer, and 2 breadboard jumper wires. Once you have all the components ready, connect the circuit exactly as shown in the circuit diagram. Before we continue, here's an important safety tip. Never connect an LED directly to an Arduino pin. Always use a resistor in series with it. The resistor limits the current flowing through the LED, preventing it from burning out. It also protects the Arduino's digital pins from damage. A 220 ohm or 330 ohm resistor is commonly used and works well for this project. Now, open the Arduino IDE software. Let's begin writing the sketch. If you look at the circuit diagram, you'll notice that the anode, which is the positive pin of the LED, is connected to digital pin 3 on the Arduino UNO. For the LED to turn on, current needs to flow from pin 3 through the LED and then to the ground pin. This will complete the circuit and allows the LED to light up. To make this happen, we first need to tell the Arduino what pin 3 should do. By default, the Arduino doesn't know whether a pin should be used as an input or an output, so we need to specify this in our program. To do that, we use the pinMode statement. The pinMode function accepts 2 parameters, pin number and pinMode. One important thing to remember is that Arduino statements are case-sensitive, so always type them carefully. Now let's add this statement inside the setup function. Because pinMode only needs to run once when the Arduino starts. Since we're using pin 3 of the Arduino, enter 3 as the first parameter. The second parameter specifies the pinMode. The pinMode function supports 3 different modes. In this tutorial, I'll explain the 2 most commonly used modes, input and output. We'll cover the third mode in a future tutorial. Since we want current to flow from pin 3 to the LED, pin 3 needs to send an electrical signal. That means it must be configured as an output. So enter output as the second parameter entirely in uppercase letters. Similarly, if the pin 3 was receiving the electrical signal, then the parameter would be input. Now our pinMode statement is complete. Next, let's write the logic inside the loop function, so it runs continuously. For our first example, we'll simply turn the LED on. To do that, we'll use the digitalWrite function. The digitalWrite function is used to change the state of an Arduino digital pin. It can set the pin to either 5 volts or 0 volts. The digitalWrite function accepts 2 parameters, pin number and value. Now, add this statement inside the loop function. Now, enter the pin number. In our case, that's 3. Next, choose the value. If you want the pin to output 5 volts, enter high. If you want it to output 0 volts, enter low. Since we want to turn the LED on, we'll use high. Make sure high is written entirely in uppercase letters. Now connect the Arduino to your PC using the USB cable. After connecting the Arduino to PC, upload the sketch to see the result. As you can see, the LED turns on as intended. Now let's modify the sketch so the LED blinks. To do that, go back to the Arduino software. Now let's add a delay statement after the digitalWrite statement in the loop function. The delay function is used to pause the execution of the sketch for the specified amount of time. The delay function accepts 1 parameter, which is the delay time in milliseconds. For this tutorial, let's enter 2000 milliseconds, which is equal to 2 seconds. Since we want the LED to blink, we also need to turn it off. The easiest way to do that is to copy the first digitalWrite statement and paste it below the delay. Now change the state to low from high, so the LED turns off. Next, add another delay statement after it. This time, enter 1000 milliseconds, which is equal to 1 second. Now here's what the sketch does. The LED stays on for 2 seconds, then turns off for 1 second. Since this code is inside the loop function, it keeps repeating continuously, making it look like LED is blinking as long as the Arduino has power. Now let's upload the sketch and check the result. As you can see, The LED is blinking exactly as expected. Now let's see how to use the built-in LED on the Arduino UNO. To explain this, we will use the same sketch we just wrote. As I mentioned in the first tutorial, the built-in LED is mapped to the digital pin 13. To control the built-in LED, you only need to change the pin value. Wherever you see 3, replace it with LED built-in. LED built-in is a predefined constant in the Arduino that allows you to access the built-in LED of the Arduino. Once you have replaced pin 3 with LED built-in in all the statements, upload the sketch again and check the result. As you can see, the built-in LED is now blinking. If you'd rather use an external LED instead, you can simply connect it to digital pin 13, like I did here. In the next video, I'll show you a simple LED project that builds on everything you've learned in this tutorial. That's it for this video. Thank you for watching. If you found this tutorial helpful, please like the video, share it with others, and subscribe to the channel for more Arduino tutorials.